Welcome back to SOLIDWORKS Live. Today we're doing something a little bit different and a whole lot of fun with our engineering YouTuber friends and our superstar teammates here at SOLIDWORKS. Now, over the past year, our SOLIDWORKS Live design sessions have been packed with tips, tricks, and downright game-changing features that have made designers and engineers go, wait, you can do that in SOLIDWORKS? From AI-powered assembly automation to ergonomic surfacing tools, we have covered it all. You'll get to see how to clean up your feature tree with tags, speed up modeling with layout sketching, and even auto-repair broken mates and dimensions with just one click. We'll also showcase some hidden gems like feature paint, the freeze bar, and even how a Stream Deck can somehow boost your SOLIDWORKS CAD workflows. Okay, I'll have to check that out. So sit back, get ready to take some notes, and let's dive in to some of the best SOLIDWORKS Live design moments of the past year.
Some assembly stuff I want to get into really quickly. Now we have things like mating that I'm going to get into, but I want to show something brand new really quickly. And that's something we're using artificial intelligence to help us out with, which is adding components or adding hardware components to our assemblies. So I have, let's see, let me minimize this real quick. Oh, actually, you know what? Sorry, in parts real quick. One more thing for parts before I get too far ahead of myself. Look at this component. Okay, so I got this cool component here. This looks good. Now, this could be done with standard cuts and bosses and extrudes, stuff like that. It could also be done with surfacing. But one thing that is challenging with this in SOLIDWORKS is that creating edits or making this a more ergonomic shape might not be super simple. And I also want to point out that although there's nothing wrong with this, when I turn on zebra stripes, you'll notice that on these filleted edges, there's sort of kind of these hard turns in my zebra stripes, which means that I don't have actual, what's it called, C3 curvature continuity happening here. So I want to show something real quick. If you're using 3D Experience SOLIDWORKS, you do have access to something called 3D Sculptor. And let me just load it up here. Boom. Now, this is a really cool tool, which allows me to use sort of a virtual clay push and pull kind of stuff to create components. I was just messing with this earlier, and of course, it closed it out to save RAM for me, which is good. But notice with this one, if I go to Tools here, Zebra Stripes, notice in those same corners that these are nice and smooth, and they flow over that corner really nicely. This, if you're creating these types of shapes, this is the tool that you need to use for this. So not only that, but we can do things like draft analysis on this too. So let's say we have this plane here. We can see that it's coloring things that are green, which satisfy the draft conditions, or yellow, which don't. So maybe I want to change the shape. So I can just easily go in here, select maybe some of these edges, pull them out, as I need to, and I can create, more green space there. Something that's really cool is let's say I select these guys, and I want to kind of change this, manipulate it a little bit. Maybe I'd change it to something that looks like maybe like this, So I create like kind of a little bit of a different shape to it. That's just super easy in X shape. I don't have to go through and find the exact sketch and change the sketch and deal with fully defining and all this sort of stuff. I can just simply go for it. So that's just something I wanted to show quickly in parts.
Nice.
Okay, back to assemblies. I think I have time for just a couple quick ones here. Let's talk about adding hardware. So I have, let me move this over here. I don't know where it went. Okay, I have some hardware here. So let me show you this. So in my downloads, I just grab some stuff, let's say from McMaster car. Okay, so I have like this guy here. Maybe I want to drag and drop this guy in. Notice that now I can just simply snap that in there. This is not a, some kind of part that has, any sort of mate references or anything like that. It's just a bolt that I got from McMaster. As you can tell, it's got the threads and everything still on it. So easily throw that in there. Doesn't work for just those though. Like, so let's say for this one, I'm going to create a quick copy of that, drag and drop it.
Mark, how did you create that copy?
I held Control and dragged it and created a quick copy. Yeah. Another great productivity tip. Thanks, Mike. So yeah, you can click and drag those and just drop them in really quickly. It doesn't work for just hardware. I have this pin here, for example. Notice the cursor feedback is telling me this is the AI recognizing that as hardware, dropping it in there. Here's another one. This isn't necessarily a washer, just some sort of cover. Click and drag it over there. Pretty good stuff.
That's really cool. So this is 2025 FTO3 because you're using 3D Experience SolidWorks, so you got the latest version. Yes. So if you're in an earlier version, this is something to look forward to. Make a note, 2025 FTO3. When you do that upgrade, you're going to get this really awesome functionality of using AI to automatically mate, downloaded component, like just pulling off the internet and slapping them in. That's super cool.
I like using Toolbox. Toolbox is great, but sometimes it's not an option. Sometimes you don't have SolidWorks Professional. Maybe you have SolidWorks Standard. So we haven't even gone into like quick mating and stuff like that. Let's do that real quick. I just want to show some examples of this, but I'll say here. So I'm just creating some copies here. But let's say I want to align these two components. Instead of going to the mate command and then selecting mates and stuff like that through here, I'm sure most people are familiar with quick mates, which is just simply selecting, let's say this face, select that face, and now I have a context-sensitive toolbar that allows me to make those coincident, for example. So this is being really slow on me, but yeah, that's that. Let's do one other thing here. I know I only have a couple more minutes, but let's show some drawing productivity enhancements here too. So in SolidWorks, let's say I need to create drawings of these items. This is also new and something that you can access again if you have access to the 3D Experience platform, because we're using the AI technology in the platform to do this. But let's say I want to create a drawing for this component and let's say this assembly. In SolidWorks, I now have auto-generate drawing. Now, this is in beta, but I can use this. Let's say I'm just going to save this to my desktop. And I can start creating these drawings. So what it's going to do is it's going to go and leverage that AI technology to evaluate the component and drop it into my template of choice. So under my default templates, I have my drawing template here. So it's just going to use whichever one I've selected for that. So it's going to evaluate it. It's going to drop it in there, and it's going to add things in there for me, like section views. It's going to add things like whole callouts. It's going to add like GTOL maybe, things like that. So here we have that one done. I'll just go ahead and open it. And now we have our drawing. And, some things are kind of stacked on top of each other, which is fine. We can just simply move those things around a little bit. So let's grab the drawing view, move it down. Oh, sorry. There we go. Grab the drawing view. Oh, it's asking me to log into the platform, of course. But, this is, I wouldn't say.
It gets you a good stride in the right direction, right? And I know that you like really hammered on this thing, and a few other colleagues from around the globe on the SolidWorks side have all been playing with this, trying to poke holes in it, really. And overall, it's like, hey, this is solid. It gets you a good start, and no need is it like intended to completely replace detailing a drawing, right? You still need to go in and check it, move things around, get it looking good. But yeah.
So and then you have things like, okay, so we've got isometric view, We have, section views that are added. So this is a great place to start. Now, if you don't have 3D Experience SolidWorks, that's fine. You can still take advantage of something similar, like if we do file and then make drawing from assembly, for example. You can choose a template that has predefined views in it. So let's say this one that I have for drawings, and this will create, whichever predefined views that you have in there, and you can drag more views in. So this is a good place to start as well. But the auto-generate drawings with 3D Experience SolidWorks really take it to another level.
Okay, so this next segment is an absolute goldmine for anyone who wants to build better, smarter models inside of SolidWorks. You probably recognize the name Jeremy Fielding, and if you do, it's probably from his amazing mechanical engineering content on YouTube. Well, Jeremy visited us over on SolidWorks Live Design recently to share some foundational best practices, like how you should always design around the main planes, how to create primary sketches that control most of your part, and the value of naming and organizing features for long-term stability.
Oh gosh. Okay. There's so many places I could go here. Thinking about the main planes. This is one of my pet peeves when I get a 3D model from someone else who has just picked some random plane and then they start designing a part that's symmetrical, but it's not symmetrical about one of the main planes. Maybe they use faces and then they create some plane that's way down in the 3D model. Stop doing that. Don't do that. Don't do that to yourself or anyone else. Use your main axis or your main planes. And I like to think of this as, and it's your foundation, right? Yeah. You built everything off of that. And so this model, even as complicated as it is built around the main planes. And then I also have another 3D model. I want to show you this one because this one has more symmetry. You can see that it's one of the planes is about the wheel, the motors that you can see there, and then the right plane right along the center of this cart because it's symmetrical. This allows me to mirror parts from one side to the other. Many of these parts are mirrored, so use the planes that are there as much as possible. That will save you so much trouble.
Gotcha.
And there's one more tip that I want to bring up before I forget, and that is something that I like to call my primary sketches. Let's open this model. So here we're in a simple part here. Right here at the top, you'll see I have a couple of sketches. This one is called the right view sketch. And then I have another one that got buried. Let's look at that. So this sketch controls about 90% of the model. And so rather than going through having to comb through all of these different boss extrudes and swept cuts, all these different things that you have going on to try to find the sketch that you need, you can control nearly the entire model from one place. And that makes your model so much more stable. Let's back out of this for a moment and then I'll come back. Here's the thing that just bugs me. When I get a model from someone else, you can tell I've worked on teams, right? Where people have all these bad practices. They will click on a face and then start sketching on this face and something will be built off of that. And then later on, because this will happen, this face will, something needs to change. The chief engineer is like, that's stupid. Get rid of that and put something else there. You delete this face and now you have all these red components and mates are broken. All this stuff is gone. Rather than sketch on a face, you could sketch on the right plane and then you can still put it wherever you want just by using features that will allow you to put it here. So, all right, let's say I want something on this face. I can actually put my sketch on the right plane and then use my, let's open this back up. And then I can use this top sketch that I made, which is all the way at the top of the tree. This is my foundation. It never changes, right? And I can use points in here. For example, I can use that point to start my boss extrude. So I have a whole video called 50 Tips and Tricks where I show you exactly how to do the things that I'm bringing up. So it will be worthwhile to check that video out. It's much more detailed and you can watch it over and over. But if I base that boss extrude from this point, it won't just vanish. It won't ever lose its foundation. It'll stay in place until I'm ready for it to leave. And you can also add names like overall width, to define what these sketches are for. Because if you work on this 6 months ago and then you're forced to move to a new project, you come back, you don't remember what all of these dimensions do. Just go ahead and add a little description. While I'm talking about descriptions, you can also name your features and then search your feature tree, right? Like come up here and search for GPS, and you can find those components related to the GPS. Things like that. This can save you so much trouble if you just take the time to name your features, rather than come here and you have 1,000 things named boss extrude. You don't know which one is which.
Right.
Oh my gosh.
Yeah, I think you're bringing up some good points. Like a lot of people don't realize, like on the template topic, that especially for parts, not only can you have like reference axes and planes, but you can actually have full pieces of geometry. Like if you always start with this same chunk of geometry as a starting point, like you can have that in the template and it's just there when you're ready to go. And layout sketches, I love. I'm a huge fan of layout sketches, right? Because you're right. It's like just go to that one spot and it can control everything else in that model if you want it to.
Oh man. Oh, okay. So I have one more tip that I want to share before we go, which is a shortcut, and that's just the S key, right? If you hit the S key, you have this pop-up menu that is customizable right next to your mouse, right? And you can just click on whatever you want. There's sub-menus in here. But what's even better than that is that shortcut has all the shortcuts under it. So if you hit S and then just start typing boss extrude, everything that you could want under every menu is right next to your mouse. You don't have to go up to the top. Like this is by far my favorite thing that SOLIDWORKS ever added to their montage. It's been there for a long time, but I can remember when I first figured this out. Oh my gosh, this just changed my world. I used to waste so much time going up here to try to search for things, or even looking through these menus and trying to find the thing that I wanted. But now I can just type the thing that I want and it's right next to my mouse. That is huge. You should get used to using those shortcuts. It'll save you so much trouble.
I 100% agree. Like that is by far my favorite thing. when it showed up, I like live and die by the S key and the customized commands on that. Jeremy, we had some additional questions come in that I think we can talk about here. Engineering Tech says, what basic knowledge should we have before learning how to make a robotic arm, or maybe how to tackle a robotic arm?
Oh gosh. Okay. So first, it took a lot of guts for me to go after this with the knowledge that I had. So it's hard for me to even describe the Mount Everest that you're trying to climb here. It is every one of the disciplines that are involved. I'm not trying to scare you off. I'm just trying to give you the most realistic picture that I can. Every one of these skills has its own mountain to climb. And then when you combine them, it's definitely the pinnacle, in my opinion, one of the pinnacles of engineering to try to tackle, short of going to space and trying to build a space shuttle. This is like one of the real, it crosses so many disciplines. I think a better way to think about it would be, do you have the mechanical design background to at least make something that, won't shake itself to death, that you can think about moving a design that has moving components, remembering that each axis is dependent upon the one below it. So if there's any play in the first axis, that's going to be added to the play in the second and the third and the fourth and so on. So any error will multiply throughout each axis. So your mechanical design background needs to be really solid. And then do you have the manufacturing experience if you want to build it yourself, to build something as complex as this? Yeah, I mean, each one has its own challenges. The electrical design is also really challenging, and because you're working with a lot of different components that need to work together. So I'm not even really sure how to explain in a couple of minutes all the different challenges that you would be going after. I think it's better to start with, figuring out where you are now, and then try to understand the gaps that you need to fill. It will be easier for you to answer the question, I guess, maybe is the way I want to answer it than for me to try to answer it generically.
If you've ever felt overwhelmed by a massive feature tree or frustrated reapplying the same edits over and over again, this next segment is definitely for you. We're diving into SOLIDWORKS' most underrated productivity tools, like feature tagging for easy organization, feature paint for copying properties across parts, and advanced selection filters to isolate and manipulate exactly what you need. It's all about speed, clarity, and keeping your workflow clean, even in the most complex designs.
Features, tips, tricks, a combination of a little bit of everything. So we'll start right into this model that I've got on the screen. And one of the first things I'll point out is the feature manager actually contains this little area over here that a lot of people, I don't know that they realize you can actually filter the feature tree just by typing the name of a feature. And part of the reason I like pointing this out is because, this part's got a lot of features. There's a lot going on there. And so being able to quickly get to, something that you're looking for, typing is, just typing the name of the feature is super, super handy. But I want to pair this with another feature that I don't know that people also use a lot. And that is tagging. And so what tagging allows me to do is allows me to select a feature, and then down here in the right-hand corner, I can hit this little tag button and I can give it a tag, and any tags that I've used show up there. So in this case, this is a cosmetic fillet. So I'm just going to select that as the tag. And once I do that, that then also is searchable. So if I type in cosmetic, immediately the 3 fillets that I've tagged with that now show up. And the other use case for this that's handy is, we talked about, the size of this feature tree. A lot of times you might want to, you've got an element of your design. Like for instance, this is the wing on this part, and it's made up of a boss extrude. It's made up of a fillet. There's actually a surface cut in here. And then there's a cosmetic fillet over here. Getting those all into, like if you were to take the approach of using a folder, getting those all into a folder could be a little tricky, just because you do still have to adhere to the way that the feature tree solves. But with tags, you can tag all those things like with the tag wing, and it doesn't matter where they are in the feature tree. And now you basically can group them together based on the design feature on the part, as opposed to using folders or things like that. So This is a super cool way of kind of getting to just what it is you're looking for and organizing your features.
I never knew that existed. And man, Sean O'Neill in the chat is saying also, wow, I did not realize that. So I didn't realize that either. I'd always just renamed my features to support this. But sometimes those names can get really long, if you're trying to describe something. So these tags are pretty incredible. I had no idea. That's great. Nice tip to start us off. Thanks, Steve.
So yeah, cool feature there. So another thing that comes into play is like, okay, so I've got this feature that is, this fillet that's in red. I've made the change, but now I want to apply that change to a bunch of other fillets. And what I could do is, the list isn't super long here, but right, I'd have to go into every one of these and go, okay, edit feature, change the value, edit feature, change the value. So another feature that I don't know, again, maybe a lot of people may have forgotten about, is what's called Feature Painter. And by default, this actually, you have to come in and go to your customized menu and turn this on. And feature paint works a lot like if you've used it in Microsoft tools or other tools. When you select this, you can paint the properties of a feature onto others. So like, for instance, the feature that we want to use to copy from is that fillet 29, that one right there. And the fillets that we want to apply it to are 2 other cosmetic fillets that we've got. So you add these in. I'm going to uncheck paste appearance properties for a minute, and you can see that it will apply those properties, like the size. You can see what it's going to copy from to what it's going to paste to, and any other feature properties that are in there. But then you can also have it apply the appearance properties as well. And so I'm going to go ahead and apply this, and it'll go off, and anything you've loaded into the paste properties dialog, it will go through and apply that to those features as well. And the nice thing about this is like I said, it's just a matter of like, I don't have to go into every feature and choose edit feature. Once I load them up, it just takes care of adding that. I will say this, you need to do like features. So like, for instance, I can't take an extruded cut and copy a hole wizard hole to it. Right. So the features need to map and need to be of the same kind for this to work. But again, feature maybe not a lot of people will know about, and it's pretty handy.
Yeah, I mean, and I think if anybody out there is like, wow, I don't, it's like I'm like just a complete beginner to SolidWorks because Steve is showing us all these things that frankly I've never seen before. I think, it's okay. You don't have to feel so bad. It was hidden after all. So, we did have to uncheck it out of a weird menu. So it's really not your fault entirely. That's actually incredible. I actually had no idea that was there either. And that could have saved me a ton of time in the past in some of my designs. So
yeah,
nice
it's cool. So let me show you one other use case for this and that is that feature paint actually will work across parts. So for instance, maybe I've got an M6 here, and I know that there's an M8 over here. So this is another, Mark, this is one that I don't know if I forgot or I just didn't know this, but if you control select 2 parts and you hit open, it will open both of them. And then you can use this little, the little sorting icons over here to stick them side by side. So like I said, I may have forgotten that, but I was like, that's really handy.
Nice. Little window management.
Yeah, exactly. So feature paint, again, just to show another quick example here, if you go in and choose feature paint, you can say, well, I'm going to take this counter bore. And Mark, you may have noticed that feature paint starts or fires up in the task pane. Mm-hmm. And not the feature manager like a lot of other features do. And the reason is because because it's in the task pane, you can go across 2 different parts. So I can take the M8 and I can copy it over here where I've got this M6 and apply it. And then I've got, that feature set of properties copied over to the other part.
Wow. Nice.
So yeah, that's so 2 different ways that you can utilize the feature paint.
I'm definitely going to take advantage of that. I wonder if it's something I can apply to like a toolbar or like a shortcut bar or something like that. Mouse gestures, maybe something along those lines. That would make it a lot more convenient than going into the menu.
Definitely. So the other thing on the kind of the realm of productivity tools, and this is one probably a lot of people may know, but I thought about this, the selection tools inside of SolidWorks, the selection command, the arrow, it's so good at kind of knowing where you're at and what you're in that I don't even think about this very much. But if you do hit the drop down, there's actually a fair number of different ways that you can select things. And I'll point out some of my favorites. So one is like selecting everything that's suppressed. So if you think about like, oh, I've gone through, I've been working for hours, I've been suppressing things or whatever. Now I need to get them all unsuppressed. I don't have to search back through the feature tree. I can just say select suppressed. It will highlight what's what's been suppressed, and then you can say select set to resolved, and I'll go ahead and toggle on any parts that we've suppressed in the background. Another favorite of mine along these lines is being able to choose select mated to. And so this is handy because if you select a part, it will select anything that's been mated to that part. And this can come in handy because you can then, right click and choose isolate. And then you can get down to just those parts that have a relationship to each other.
That's really handy. It's way better than the breadcrumbs and all that stuff I've been trying to finagle with. So that's really nice.
Yeah. So I love that one. I also love the ability to select toolbox parts. So this assembly has a lot of hardware in it. Selecting toolbox is an easy way to grab all of that, especially if I want to suppress it or turn it off. You do run into cases like this assembly, though, where it's got a lot of hardware, but they're not toolbox parts. I've worked with customers who, for whatever reason, decide not to use toolbox. They build out their own libraries. Doesn't have the toolbox flag. So this option right here to select identical components is really handy because all you got to do then is select, this piece of hardware, and it grabs every one of them that looks like that, or every instance that matches that. Right. And so it's a way that you can still quickly make selections, make suppressions, those types of things without, without having that toolbox flag in there. So another kind of cool little productivity tip there.
Up next, for the next 10 minutes, is a segment full of practical problem solvers, especially for anyone who's ever dealt with broken mates or dangling dimensions or underdefined sketches where they shouldn't be. And once again, that probably describes all of us, right? You'll see how SOLIDWORKS 2025 introduces auto repair tools to fix common issues with a single click, and learn how to use sensors and the freeze bar, and like I teased in the beginning, even a Stream Deck to boost your productivity. Plus, we'll look at how macros, yes, even ones written with AI, can automate repetitive tasks and improve model stability. Tons of tips to help you work smarter, not harder, from, actually, yours truly. So a few other areas here to look to leverage within the interface these days. So this came out just a few years ago, and it continues to be developed, but this auto repair mates option. So a lot of times we have cases where mates can blow up. Maybe we've over-constrained something, or maybe a reference has been broken. Well, now you can select via right-click or via the context menu this auto repair option, and SOLIDWORKS will attempt to auto repair the mate. And it'll give you this green dialog box if it is successful. Let me know in the chat if you have tried this already and if you had success. I would recommend, whether it's for dangling dimensions, as we'll see here, or with auto repair mates, that you just take a second, take a beat to examine what's been done. I know our software, any software that we use, right, whether it's SOLIDWORKS software or otherwise, can help us speed up our processes. But at the same time, I do, as a human, want to have an assurance that I've given something a once over to make sure that it is correct. In this example, I don't find myself, or I haven't found myself, going to display delete relations a lot. However, we now have this new button in the interface called Repair All Dangling. So if you have a case where you have a lot of dangling dimensions within a part, you can try this Repair All Dangling and see if it can fix them. Once again, make sure the design intent is intact after it's been fixed. But I do recommend using that, or looking to use it potentially, if you have, let's say, one or more dangling dimensions, just in case SOLIDWORKS can fix them for you. Akin to that is in drawings. We can reattach dangling dimensions here. So now we're able to do that much more efficiently, as you're seeing in this quick demo. Reattach, right click, reattach, and then you go ahead and reattach it to the entity. A lot quicker, a lot easier than the way that it used to be. So you might say, hey, I can just delete them and reattach them. That's fine. But just know that within the interface now, within your workspace, you now have the ability to just do a simple right click, reattach the reference as you see fit, move about your day. So a lot of you are using 3D mice. We still have, I was just talking to a beginner SOLIDWORKS user yesterday. This is a goofy spoof we did for what's new. We can see that little white device there with all those buttons. That's a Stream Deck. So essentially a Stream Deck is, as you see there, it is a pane. It's a device with different, different button layouts. So you have different rows of buttons, and it's a very simple software interface that hooks to it. So I believe Elgato is the manufacturer, and essentially you can map it to keyboard shortcuts. You can map it to opening programs. I see Alex Worsfeld, much easier than trying to grab the tiny dot. Yeah, that's what you used to have to do in drawings, right? Alex there talking about let's see, he's talking about the reattach the dangling there. So thanks for that comment, Alex. Yeah, I agree. That used to be a pain, by the way. So I used to teach the drawings class for SolidWorks, and man, that was not fun. It was because it always used to be like it would be really hard. You're learning how to use something newly, and it would be really hard to get the show up, and it would be really hard to get the tiny dot. And then once you get the tiny dot, it'd be like, all right, well, I had to try that like 4 times, so I'm just going to delete it in the future. But thanks for telling me, and you would just break it. So yeah, but look up the Stream Deck. It's kind of like a shortcut device, if you will. Once again, you can map keyboard shortcuts to it, map program launches to it. You can do a lot of elaborate things with it. You can get bigger ones, smaller ones. I think the smallest one they offer is like a 4-button one. So if you wanted to kind of expand your device usage, if that's something you're trying to do, expand your capabilities, yeah. And a lot of 3D mice as well. They have a lot of buttons attached too. So, but yeah, I wanted to call it a Stream Deck because it doesn't seem like it would be a SolidWorks tool, but you can map a lot of things to it. Think like if you map a keyboard shortcut to a macro, then essentially that could be like your macro area, which is kind of neat. Okay, so sensors. There could be a whole deep dive on sensors. Sensors are part of your workspace or part of the UI. If you look in the on the left hand side, they're on by default. Essentially, what we're showing here is an area where a part has gone outside of the boundary of its sheet metal bounding box, which was added just a few years back, the ability to add a sensor within that specific property. So it will give you an alert, essentially, kind of show up as an error if you've gone beyond it. So you can kind of parameterize your model in a bit of a deeper way. So sheet metal bounding boxes are not the only way you can do that. You can use these with simulation. You can use sensors in a whole lot of different capacities parametrically. So just know that that box is not there for quote unquote someone else and not me. You can right click it, add a sensor and explore it, look at the help. I definitely recommend looking at that if you want to work maybe a bit smarter, a bit more efficiently. It might work out for you, it might not. But this is an area where I just find it's massively sort of underspoken about. Okay, so exploring S key, keyboard shortcuts, and locking features with freeze. So let's head back to SolidWorks here. All right, so let us open a part with features. I tried it when I was using a command predictor. I was like, oh man, of course I pick a part that has no features in it. All right, let's see. Let's actually just make one. All right, so make our part with a hole in it. There's the S key. Boss extrude. All right, so make a plate with a hole in it. So grab this, go ahead, make a sketch, and then use my S key again. Circle. Okay. And then I will extrude. So doing a lot of typing. Typically, when I have my interface set up, I will, this is kind of set up to stock settings. You'll see within sketches, within the S key interface, it has certain buttons. And these buttons I use quite commonly, don't get me wrong. But you can also add them here. So insert the command there. And then you'll see from now on, when I press the S key, such as the case with cut, I have the extruded cut there. So the extrude cut, right click through all, press D, how many of you knew this? So if you press D when you're in a feature execution or within a sketch, it gives you the confirmation pointer right next to your cursor. D as in dog. It's a pretty neat one. All right, so it's a very simple part, obviously. Just to show an example, we have something called the freeze bar, which we introduced quite a while now. So if you go up to your options and search freeze via this search box, you'll see it's in general settings and it's off by default. But what this can do is it adds this little golden bar, kind of looks like the rollback bar. And instead of starting from the bottom, it starts from the top. And what it does is it basically locks from rebuilding these features that are above the golden line. Now, the usefulness of this is, for example, let's say you have like a very hack and slash sort of surface model part where it was surface extrude and it was surface cut, and you know the deal. You just keep basically hack and slash, surface modeling, whatever. This is a potential usage for the freeze toolbar because if it's not rebuilding, if you don't really care, if it's not rebuilding every single time the feature tree, it can make it a little bit easier for the model to regenerate and thereby be accessible to you for further options. So I definitely recommend looking into the freeze bar there. It's under the general tab in options, or once again, as you saw I did there, just search the options for freeze. And we don't have a lot of options with freeze in the name, so you'll find it. All right. Awesome. Good to see lively chat here. Okay, so what we'll cover here, we're kind of winding down the episode here with topic area 6 of 8, sketching and feature integrity. Once again, we've already gone over some sketching areas, some feature integrity areas, but we'll go through a few more here. So I'll show you that macro that I created, and I'll talk a bit more about using an LLM like ChatGPT, at least in my observations for making macros, and some common, I don't want to say pitfalls, but just some things to look out for, things that maybe it gets wrong. It gets a lot right, to be honest, but things that it gets wrong and the kind of ways to fix them. So I'll show you that. I'll also offer this macro out. If anyone wants this underdefined sketch report macro, I'm happy to upload it. So just let me know, and I'll add a link in the comments after the episode. Evaluate tab review, some tools there that I think you should keep aware of, and then check sketch for feature, which is a tool that can come up, especially if you're a beginner user, that I recommend looking to leverage here. Okay, so under defined sketch report. So how am I going to add that? So I'm going to go to evaluate here, and then I'm going to right click and then go to customize. A few lessons I want to add here just while we're here. So essentially what I'm going to do here is I'm going to add a button to my evaluate tab. It's going to be a macro button. So you can add macro buttons to, once again, keyboard shortcuts or mouse gestures or to your command manager tab. And so if you go and search under commands for macro, you can drag and drop this icon here that says new macro button to the command manager. And you'll notice when I do that, what it asks me for is to customize my macro button. So the first area it's looking for me to customize is just tell it which macro I wish to apply to that button. So go ahead and grab that. So check under defined sketches, open, and then I could even do a custom icon for it to make it look like a real feature. So you might be wondering, where'd you get this? So you can make your own icons, of course. In Illustrator, you can have Adobe Illustrator make icons for you. There's also resources like flaticon.com, which I'm a member of. And flaticon.com gives you a lot of really nice PNG items, or PNG images. Now, you'll notice that it's looking for a bitmap file. So essentially what I did was I went to Flaticon, I downloaded a PNG, and then I went into Microsoft Paint, and then from Microsoft Paint, I basically saved it as a bitmap, and then it makes it compatible for this particular menu. So see, it adds it there. So tooltip is the name under defined checker, and then for prompt, let's see, checks sketches checks model for underdefined sketches. All right, so there you go. There's our new feature in SOLIDWORKS. All right, so let's see here. So I have in this really simple piece, this roll of duct tape that I created, there are two sketches. You can see the minus sign, which means they're both underdefined. Now, if I select this here, you'll see underdefined sketches found, sketch 1, sketch 2. Okay. And then just to prove it works and it's not static text, I will fully define this circle. Let's just make it 55 millimeters in diameter, leave, and then run it again. And then it says, okay, underdefined sketches found, sketch 1. So this is a macro that I was able to get from ChatGPT. I will say, however, that with regards to this macro, if anyone's interested in using ChatGPT or something similar for just grabbing macros or trying out different ideas for macros. So I'm editing the macro here. So I think one common thing I've seen, let me know in the chat if you've seen it as well with different LLMs, is if you ask it for a macro, which again, very impressive that it's able to do this. Sometimes what it will do is it will make up API calls. So don't get me wrong, amazing. I mean, it's really awesome. It even comments things for you, which is great. So it gives you a bit of an idea of its thought process, I suppose, in terms of generating the macro. But sometimes it'll get API calls wrong. So for example, like in this case, I had to fix this so that it used the proper call for this get constraint status. I think it misapproximated the call and just called it like get sketch status, which I don't think is an API call officially. So there will be little things like that you'll notice where it will get it wrong and then you'll run the macro and it just won't work. So sometimes they do, I'd say oftentimes actually it does take a bit of debugging in that way, but usually it's just one or two calls that are wrong. So if you can spot them, then you're probably okay to fix it. And honestly, a lot of times, if you use the SOLIDWORKS forums, which again are now in the UI, you can just go to the SOLIDWORKS forums and ask someone, hey, why is this not running? Even if you're not familiar with VBA at all, or the SOLIDWORKS API, and somebody will probably help you.
This next segment is a look inside the making process of Aryan Falahi, who has the largest self-hosted, self-run SOLIDWORKS YouTube channel in the world today. He shows you how he thinks and moves from idea to 3D print. He also shows how he uses SOLIDWORKS tools like fillets, simulations, and design iterations to turn a simple strip light into a sleek, printable, and structurally sound fixture in his living space. Along the way, you'll get a dose of design philosophy, the importance of stepping back, rotating your model, looking at it from different perspectives, right? Testing with simulations and catching those design for assembly issues before they become your actual project showstoppers. It's thoughtful, it's practical, and it's packed with lessons every maker or designer can use today.
Okay. Now the strip light can go through, but it looks a little bit brittle. We are working with sharp angles. So let's just do some fillets. It just reminded me of a presentation slide I saw at 3D Experience last year in Dallas. There was a meme that engineers were modeling something and somebody said, can you make that product look a little bit better? He said, sure, let me just add some fillets. So, yeah, it does make it look better.
It always does. Yeah.
It kind of does. Yeah, it's satisfactory. Yeah. But it also adds some strength to it. So we are not working with sharp angle 90 degrees so they cannot break. So I'm like, okay, this is a good foundation for me. I go to the next step. The next step would be for me. Sorry, I just jump between the models all the time. The next step for me is usually rotating the component. It's kind of a habit for me. When I'm done, I keep rotating the component and I look at it from different angles without thinking about anything specific. Because every time I've done that, something comes to mind. Oh, why is it like this? Why should I do this? Oh, how do I fix that? Oh, there should be a problem there. It's always good not to take action right away and take your time, go back, look at it again, maybe even stop working with SOLIDWORKS, take a break, come back again later. I assure you, there is always, always, always something that you have missed or you should still do. That's a guarantee. And after doing all that, I still miss something here.
Yeah.
So
yeah, it's a great way to self-review your work, and it gives you a lot of chances of improvement, and in your design process.
definitely, you need to catch your own errors. I've reached this step and I'm asking myself, okay, I am going to 3D print this from PLA and I don't know. Is it going to be stable? Is it going to break? Is it going to bend? That's a question that I was asking from myself. And I was like, why don't I test this? Fortunately, I have the basic license for the simulations. Okay, doesn't matter. I can run it again. So what do? I define the fixed surface on the top where it connects to the ceiling, and I just add the gravity. And I just measure the displacement on the red spot, which is about 5 millimeters. It wouldn't look good if it bends because of its own weight. And on top of that, I'm going to add the LED strip light to it as well. So I want something that is sitting flat, doesn't move. So this one looks good, but it's not doing the job properly. So we need to do some optimization. The first thing that came to my mind was, okay, how about I cannot click on anything. 1 second.
Yeah, maybe is there a window open, or maybe?
Yeah, probably I have to check. What is this? I'm going to reopen this.
Yeah.
Okay, so we had a displacement of 5 millimeters. Now, the first thing that comes to my mind, this can be chamfered. Let's just do it this way, really quick. And I go back in and I run it again. And I get this. Okay, what do I have after the chamfer? 3.5. So I just reduced 1.5 millimeters of displacement, like 33%. So that's an improvement, but maybe it's not enough. I keep doing things like this nature. Maybe I chamfer this as long as it allows me to do it, as long as I'm okay with the look. Maybe it doesn't look good, then I have to find another solution, maybe make it thicker. The wall thickness, instead of 3, I can make it 4. And after playing or iterating with this, I ended up here. It looked like this.
Amazing. So, Aryan, I remember we casually do the simulation and then do the modification. So now, if I just think from a designer's perspective, so we have this you can say advantage of CAD embedded simulation available inside SolidWorks, which basically help me to do the setup of my simulation problem, run the analysis, and then simply go ahead, make the design change, and then just rerun the analysis again. So now imagine if your if this integrated simulation is not existing, then eventually it's pretty hard to use a separate software for doing analysis, coming back, doing import and export, doing this analysis setup once again, and actually it eats up a lot of time. And this is where our integrated simulation basically gives us advantage of doing all these iterations in a very quick way.
It does, definitely, 100%. It's seamless. That's what it is.
It's seamless, yeah.
Yeah, that's the simplicity is very important. You might
True.
have a very good speaker at home, very good camera, very good radio, very good calculator, but your phone does all of that, and usually you don't want to jump unless you have to, unless there is a very special case, because when everything is under one roof, it's easier.
True.
And I just wanted to show the end result, which is 6.4 to the power of minus 1. So it's like 0.6 millimeters.
0.6.
Yeah, so it's almost negligible, and that's good enough for me. And one thing, another challenge that I did face, which I cannot show here, or maybe I could, is when I decided to actually sit down and print this. When I wanted to do that, I saved this component as STL and opened it up in my slicer program, and I realized the volume that my SolidWorks, the volume that my 3D printer could offer was not big enough to accommodate this design in it. Okay. So at that point, I'm facing a new challenge. Let me just try to add this. Maybe you want to share that. No, I already have. So I cannot share that. But it made me come back here and reduce the diameter. Because at that point, I had a couple of choices. I could segment this and then lock them together to keep the diameter the way it was.
Exactly, yeah.
Or I could make it smaller. So again, this was a self-defined project. I had all the flexibility in the world. You don't have that all the time. Maybe your employer has given you a task. Maybe your client has given you a task. You need to stick to some criteria. But I didn't have that limitation over my head. So I made it smaller. And I have to say, the other wall lamp that I showed you in the beginning, that's 1.5 meter in diameter, and that's consisted of over 32 components that I have connected together. Wow. Otherwise, I could have not, printed that at one go. So after I did this, and I was happy with the results, I printed it. This is it.
Amazing, yeah.
This is how it looks like. The strip light can go inside it. I'm gonna cut the wires and connect them directly to the ceiling myself. The wire sits inside. Everything was good until, are you seeing my top camera too?
No, Aryan, we can't see your top camera.
Can
you hold it up to your main camera, the front camera?
Sure. So
yeah,
it sits inside it. Everything was good, and when I tried to connect it to the ceiling, I noticed an issue for the first time. If you pay attention to the holes that I have here, they look fine, and I already took the space into account to put the screws here, and it's fine. But the second one here is hiding behind the bridge, so I could not screw it to the ceiling from here, and that made this design obsolete. If I had spent more time looking at my design, I would have noticed that this hole that you're seeing on my screen is actually hidden behind the bridge. So I had to go back and end up on this.
Yeah, I would you can say categorize it as a issue of more from the design for assembly perspective. So where I was not able to assemble it because of the design issue. Yeah,
absolutely. This is something that I knew, and I did not follow myself. So it's happening. All right. After this, the next step is actually this is the new design. Again, you're looking at it here. The holes are displaced. We have the capacity to connect it to the ceiling. The opening is here. The bridge is here. and it's actually really robust. I can move it if I apply force to it, but on its own, it's going to be stable. And this is one example of designing something from scratch. I know the example wasn't very attractive in the eyes of mechanical engineers. It's simple, it's one component, but I just wanted to bring the spotlight to the thinking, the actionable steps behind it.
Okay, that's a wrap. That's a wrap on our highlight reel today. Now, hopefully you picked up a few new tricks or you rediscovered a few features that you forgot existed, courtesy of all of our friends here on SOLIDWORKS Live Design. Now, if something sparked an idea or made your workflow easier today, drop us a comment. Let us know what stood out. And of course, subscribe so that you don't miss what we have planned next here on SOLIDWORKS Live Design. Thank you so much for being part of this community, and we will see you on the next SOLIDWORKS Live. Take care.